So in last class we have seen about the concept of phasor relationships. So the phasor relationship of the resistor, inductor and capacitor. So before continuing with the other remaining phasor relationship of RL, RC and RLC circuits, it's better if we know the prerequisites before solving those concepts. So in order to solve the phasor relationship of RL, RC and RLC, it's mandatory that we should know about the concepts of the power triangle, the impedance triangle and as well as the voltage triangle. So in order to do voltage, impedance and power triangle, it's required for us to know about the instantaneous power, the average power and RMS power calculation. So based on which we could able to see the power factor and as well as the power triangle concepts. So this is the order. So once we complete that, we will be relating all those the triangle concepts with our phasor relationship for resistor, this RL, RC and RLC circuits. So with that we will be winding up this chapter. Okay. So now let's start with the instantaneous power. So it's a very simple concept. The power drawn by any element at instantaneous time is called as instantaneous power. So here I have just mentioned, so the instantaneous power is equal to the voltage across the element times the current which is being flown in that particular element. Okay, the product of voltage across the element and the current is generally called as the instantaneous power. And we know this relationship. So V of t is nothing but Vm cos omega t plus theta, and I have just used two new things called subscripts of V and I just to represent that this angle is for the voltage and this angle is for the current. Okay, so when you just substitute here, so you will be finally ending up with this particular equation. So where we need to just can able to recalculate this particular equation by going through this formula, the trigonometrical formula. So we can replace cos A and cos B as cos A minus B plus cos A plus B by 2. So just substitute that thing over here, and now you could able to find the final instantaneous power which is being flown in the circuit. So what is the final thing? So you have two different things. One is time independent equation and time dependent equation. Okay. So when you look at time dependent equation, and if you look closely into the frequency, so the frequency of the instantaneous power is actually twice compared to the voltage and as well as the current. The frequency is twice compared to the frequency of voltage and the current. So that I have mentioned over here. The frequency of average power is twice of the frequency of voltage and the current. So this is the concept of instantaneous power. So next topic we will be covering about the average power. Stop and here. Stop.